Yeah, that's why I was not worried about it.
Good afternoon, sir. Shekar. Good afternoon, sir. Myself Nishkash. I am from VITP University from Amravati. I am a third year BTech CSC student. My paper is about analysis of median Gaussian and Butterworth filters under consistent and varying noise conditions at multiple filter sizes. So in this paper, I will be covering about image distortion, noise models, filtering techniques, what is the methodology I use, and what the results I got for Gaussian noise, salt and pepper noise, speckle reference paper. So let's understand what is image denoising. So image denoising is just the fact that if some noise is present in the image, how we will be removing that noise from the paper. So there are noise types are Gaussian, salt and pepper, and speckle noises, which are being used in paper. And we have understood that no single filter works best in all cases. The objective is to compare median Gaussian and Butterworth filter using the metric as an assessment. So Gaussian noise is an additive noise which works as a normal distribution caused by sensor or electronic interference. It is smooth but random variation that reduces overall image clarity. Salt and pepper noise appears as random and black and white spikes caused by transmission errors of body conversion, best handled by non-linear filters. Speckle noise is multiple common in SAR, ultrasound and MRI imaging. It produces a granular texture that obscures fine image details. So we have used these three types of filters to reduce the noise in our image. Median filter, which is a non-linear filter effective for spiky noise. It replaces each pixel's value with the median of its neighbors, excelling at preserving edges while removing outliers. However, its effectiveness diminishes with excessive noise. A Gaussian filter is a linear filter with a pixel-shaped curve. It effectively reduces Gaussian noise but can lead to blurring of fine details, especially with large kernel sizes. On the other hand, Butterworth filter operates in the frequency domain, offering a gradual transition between low frequency preservation and high frequency noise suppression. This ensures smoother results compared to average frequency cutoffs. So we have used this methodology. First, each image was synthetically corrupted with controlled levels of Gaussian, salt and pepper and speckle noise to simulate real-world conditions. Then we have used median Gaussian and Butterworth filters to the noisy images. The filters were tested across different window sizes, 3x3, 5x5, 7x7 and onwards, to observe the behavior and optical parameters. We have used the mean squared error MSE metric, was measuring the average square difference between the denoised image and the original noise-free image. The lowest mean created the best difference. So these are the results which we got for Gaussian noise. Here we can see that the Gaussian filter remains the constant irrespective of the window size. The median filter keeps on increasing. The MSE, which is the median filter, on the other hand, the MSE keeps increasing. blurriness in the image, while the Butterworth filter gives the highest amount of MSE, that is the most blurred effect at lower window sizes. For salt and pepper noises, the median filter works the best for low window sizes. The Gaussian filter again works at the same rate for all the window sizes, and the Butterworth filter keeps on decreasing based on the higher window size. Speckle noise, we can see that the Butterworth filter keeps on decreasing based on the higher window size. The Gaussian again remains the same, and the median keeps on increasing. From this, we understand that no universal filter performs best in all noise conditions. Filter performance depends on noise type and window size. Larger windows improve denoising but often blur image details. For median, it was a for noise and reducing the blurriness in the image at extremely small window sizes. Gaussian filter, it works best for Gaussian noise at all window sizes, and for extremely high large window sizes, the speckle noise, Butterworth filter works best for removing the speckle noise. These are the various references I have used in my paper. The different filters and noises. Thank you.
When you start with the filters, were there any threshold values that had to be compared and have reached the threshold value?
Sir, we had kept along the window sizes. So for what we had decided for a specific window size, we can't actually compare because it's just one
What
value.
is the size of that window?
We have used for various 3, 7. So it works best for salt and pepper. But again, it won't work great for speckle as well as for the medium filter.
When you take an image, what was the pixel rates that have been maintained with those images?
It was normal 256%.
Only it was with the black and white or grayscale or with the...
What I had done was it was an RGB image. We had converted it to a grayscale image, and after that we had performed the operations.
If it is a high definition image, what is your thought to continue with your work?
First, use the amount or something like that. We can make it to a constant value 512 cross 512 or something like that. After that, we can perform the images.
How do you implement these to the real world applications?
It depends. Like if someone is choosing a filter to remove a noise, if an image is there, so to understand that what image what filter works best for removing what type of noise, this could work in that way.
Did you find anywhere the type of complexity taken or compared with this filter?
I have taken the values which have come in the research paper. The values we have compared for 3 cross 3 to 100 cross 101 cross 101, but each single value we have taken from MSM matrix and understood what difference it is for each filter on different noise.
Time consumption to extract or filter the data.
So time consumption we have it also.
Because it may take more time, as you have stated, 3 cross 3 or 5 cross 7 or 7 cross 7. It may take time larger to the extent to get it filtered. But that time is when you want to put up with the next level of applications.
So actually we have done this. I have done this using MATLAB. So the time wasn't much of a problem for me considering these camera.
Because if it is more data, smaller data is fine. When you have multiple types of data, larger set of data, at that time this comes to picture.
For that, for doing collab with MATLAB.
Thanks.
Thank you so much.
Thank you for the insightful presentation. Now let's call upon the paper ID 607.
Welcome. I am Vijay from ICITIEICS. So today I am going to present paper. So secure model deployment in space. So that is enabling the encrypted inference and OT updates in a containerized edge environment. So it includes some content that we will discuss in the slides. So it will include from the what is the problem statement, what actually we need this, and what are the overall discussion, and what will be the future works. So the problem statement was when on the satellite itself, there are some certain types of attacks can happen, some data breaching might happen. So, but it is very crucial when the application basically more onto the defense side or more to the statistic side, right? So, once a model trained on very sensitive data, when the all these models are deployed on the, let's suppose, some multiple satellites. So, when it's in the control of the organization, satellites cannot cover all the areas or AOIs, so we may need to expand into the multiple constellations of the satellites. In such scenarios, the security of the data and model becomes a critical point. So, to get it from it, we have developed some containerized environment which will run as part of the encrypted environment and containerized environment basically. So it will give more additional security to the model execution, and whatever the data is processed for the defense use will be highly secure, and it will give a certain level of reliability and confidence that the data and whatever the processing happening on the model side will remain secure here. Also, just a note, here some use cases are there, when we are doing any operation on the ground, we have a lot of liberty to go in person and change the model, update the systems, all these things. But once our application is there on the satellite itself, so also to communicate with these, we need to update the models over the time, right? So there are some challenges are there. So one is the uplink budget itself. So uplink budget as in here we are getting 4G to 5G speed, and in which we can transfer the data in high speed. But on the satellite, we are from ground station to satellite, we will be getting a certain window where we will be uplinking and downlinking our data. So such research request to according machine learning model or this model with some size of the MBs and all these things. It will require some time. In the meantime, our pass will happen. So again, we have to wait for the next pass. So to overcome this, we have created like OTA updates here. So how OTA updates work? So basically, one version we have uplink with the base version of the satellite as a part of the payload. Right. The next time, what will happen? Let's suppose it is detecting some updates, but it is not detecting which actually we want to. So instead of uplinking the whole model as a part of the replacement, what we can do is we can take out the difference between both the models in the layers wise. So what is the actual delta difference of the layers? Let's suppose today I have trained which includes some 10 layers, and tomorrow the next model includes some 12 layers. So instead of pushing it all 12 layers again, instead of that I can take the difference, delta difference from here, and what is there, we can pass the artifact, and the artifact can be encrypted and can be uplinked to the satellites. And so artifact will include some signing keys for the verification that whatever the data I am getting is correct only, correct or not. And the same keys if we pass, same key will be present on the edge environment, the storm which we are saying here. So the same will be present on the satellite itself. So after cross-checking that the key is and then further process the pipeline and it will execute properly. So on the encryption side, what exactly we are doing? How we are encrypting our model to secure the run, to secure the our data processing on the model side. So we are doing one. So right now I've taken the example here and the experiment on the ONET side. So we are converting using the AES 256 algorithm. So which is very hard to break, require the iterations of the 1.1 to the 10 to the power 77. So which becomes very complicated scenario to break it. On the other side, So on the other side, it like in a containerized environment is running. So all the resources, whatever we have put, will be in that certain limit system. So here I have explained how the complete environment will be working here. So initially into the search with the model. From search, it will go to the satellite mission control center, control and command center. So it will include updated file plus task, whatever the area that you want to capture, and from there it will be uploaded through the satellite. On the satellite, obviously controller onboard computer will capture the data from the sensors, and then it will pass to the onboard edge computer device, which is called ISTOM, which will contain all the pipeline and dependencies with the OT update mechanism. So it will apply the OT updates and application here, and will execute in the containerized environment. Okay. So here containerized runtime environment also include when we are extending to the multiple constellations. So there are some certain types of limitations that we can provide X number of RAM and X number of GPU users limitations. So here on the container side, what we can do, we can put the limitation that it will not grow more than 3 MBs or 400 MBs of GPU MBs, and all these things we can pass it here, and application will run using those containerized environment only within the resource limitations. Then okay, the system architecture I have just shown it again. Okay. And what was the outcome here when we are doing the OT updates? So OT updates, like when the initial, let's suppose for a model, it is taking the full upload. Then instead of this, if you are just pushing the OT update, which is the data difference of two models, we will be taking only just 22 seconds to uplink it. And also it will cross check if the hash value of both the models is not the same, then it will reject the model and the OT update and will auto recover in less than 5 seconds. Okay, so what are the limitations like here and what are the feature works that we have included here? The model sets because we are using with the PKI infrastructure, so which will utilize the public key and all these things to run the all the things in the secure environment. But right now, the payload which are not radiation hardened might flip the bit, and the results might be some plus and minus. So next target will be there in the future work, and these are limitations that we will address also. And next, as we are growing and mentioning about some test also. So when we are uploading to some model, so orally we cannot commit. So at system level, there should be some communication mechanism which will give the remote attestation for the trusted computing. So some key-based authentication should be there that this is trusted source. We are applying our hardware, our container as our software application there, and it will be running in the secure zone, and there will not be certain data loss because here we are mounting some part input. Everything is containerized. So that's all.
This is a prototype. Educated satellite communication for your work, or just it is a prototype?
No, it's all already we have done 6 missions. Yeah, actually.
How is your firewall protected with that data? Firewall security should be done as you have done with the encryption and this security. If the firewall supported, when you pass on the data, how it has to be done?
Okay, so firewall and all this rule is already applied, right? Which port number the data will be accessed, which are the only port which we have allowed to data transfer. Other port, if the request is coming, we will not allow. Also, from ground station to satellite, there is like some authorized communication channel is there, right? So we know that if the authorized channel is there, this and with the PKI infrastructure, so we know that this is publicly authorized to share the data. Then only it will share, otherwise it will reject. Right. Okay. So we are working with so many clients here. So including the government and non-government also. And recently we worked with NASA JPL Jet Propulsion Laboratory also. And in India, you know, don't know put the name.
Are you a research scholar or an employee of the company?
I am an employee of the company.
Yeah. So with the company.
Yeah.
Thanks. Next one. But still more enlightened because you are with the corporate culture. Many things cannot be displayed.
Yes, right. So there is some limitation. So that's why I want to mention I can do this, but I can share whatever I can.
Thanks.
Thank you, sir.
Thank you for the knowledgeable presentation, sir. Now let's call upon the paper ID 1036.
Good afternoon, everyone. Myself, Ankitha, and I am here to present my paper which is my paper is basically on predicting equal employment quality in Manchester development. Firstly, we need to understand talk about this equal employment quality. That simply means the overall condition of either that person who is the resident of that particular building, how much comfortable he is feeling, and what kind of pollution, what kind of the conditions of pollution are there in this that particular building. So the factors related to visual air quality we can divide it into two parts. First, C related to air pollution. There are some particulate pollutants also, PM2.5, PM10. The concentration of these we consider inside air pollution factors, and there are residence comfort indicator also, like temperature, humidity, or lighting conditions. So in this work, we try to predict these IEQ parameters. So what's the reason behind this? So basically, like if we are able to predict temperature or humidity, we can reduce the energy consumption. In addition to that, if we can predict our air pollution factors, then according to that we can do some changes so that the pollution level of that building could remain normal. And there, in addition to that, these heating, cooling, and lighting conditions also we can monitor continuously. These are the some previous work related to the LSTM for predicting different IEQ parameters. So in our work, we have taken these parameters CO2, PM2.5, PM10, temperature and humidity, and we collected all these data using different buildings of Presided Bangalore, and then we just took average of then we trained our ML model according to this data, and then we try to predict next 1 hour AQI parameters. So firstly, this figure shows the environmental monitoring setup of this particular work. So we have different sensors which we have installed in different buildings, and then for communication we wanted to see this one microcontroller. Through that microcontroller we are transmitting that data using Wi-Fi, and then using this Wi-Fi gateway or Wi-Fi router we are receiving that data, and all these things we can visualize in our dashboard application. In this dashboard application we can also see the predicted values of all these AQI parameters. So for IEQ prediction we have used first one is LSTM model, which have 2 LSTM layers using 10 and 5 units. Then little bit modification in this model, we have added one self-attention layer also with LSTM model. Then we have used a hybrid model which consists of CNN and LSTM, and then finally a model consists of hybrid CNN and LSTM model plus attention layer. For different IEQ parameters, like for temperature, humidity. For temperature, we can see that the hybrid temperature and humidity, hybrid parameters were showing highest RS square value and lowest RMSC value. And for other parameters like PM2.5, PM10 and CO2, our hybrid CNN with a value of R square and lowest value of RMSCs. These are some of the plot. This first one is related to temperature and second is related to PM10 values. So we can see that our model is predicting almost similar values as actual values. So in addition to this work, we have also used one method which is for calculating our used for calculating index value of indoor environment. For that IEEE parameter, this basically consists of two parts, IAPI and IDI. The formulas for calculating these parameters are shown in this slide. Using this, these values are calculated, and finally the final index is calculated. This IEEE value has IEEE is in range 0 to 10. If your value is greater than 6, that means that building condition is not good. So from these results, we have seen that for the temperature and humidity, normal hybrid CNN and LSTM model is providing best values, but for other parameters, adding self-attention based models were providing better values. So in addition to this work, in future we want to incorporate buildings occupants symptoms data also. We want to use an ANN model, and we want to use occupant symptom data also to evaluate how this IEQ or environment quality is affecting the life of those residents. These are the references. Actually, there was one project of Senior Bangalore related to smart airport terminals. There was one project of Senior terminal. This work is a smaller part of that particular big project. at Bangalore, from Bangalore.
This is a very, very essential thing for writing.
Yes.
You have to get limited with things at Canada and foundation. There are interest to analyze and give some sort of a target for smart city building, green building technology.
Yes, sir. We will surely in future. Right now, it's a part of a big project related to smart airport terminal, but in future we will try to work with
Please
others.
get in touch with Karnataka State Pollution Control Board, which is in MD Road.
Okay.
There, of course, there are government people, but this type of analysis will definitely needs for particularly Bangalore. You know, Bangalore is one of the highest pollutant city. Good analysis, but okay, I was not able to really understand how this particulate PM10 and all, is it in the public air or it is inside the building?
So right now, though, the sensors which they have used are within building of CDEC Bangalore only. But later on, they will try to use those sensors in other buildings of Bangalore also. Right now, the complete data is from CDEC Bangalore building only.
It is a very, very essential for a highly polluted city, but such type of analysis we should share with the government people, where they can take a decision for implementing standards. Thank you.
Thank you. Now let's call upon the paper ID 1468.
Good afternoon, Vemana. Bengaluru. Good afternoon, sir. Our paper title is Solar Panel Fault Detection using analysis of deep learning models. Solar panel is most basic and known by everyone. Solar energy is one of the most top renewable energy sources, but due to many issues like physical damage, electrical damage, and bud drops, because of these damages, there will be so many issues to directly save the energy. So, solar panel fault detection. So, what are the different types of faults in solar panels? We address those and we detect the major faults, like classifies whether it is the solar panel is a good one or a defect one. So, actually, the main problem statement of our paper is there will be so many defects in the solar panels. It open to the environment, there will be so many weather issues. Because of that, there will be so many solar panel defects, like bud drops will be there, and so many electrical damages and physical damages will be there. So our paper classifies the solar panel into a good solar panel with clean solar panel or whether a defect one, using deep learning techniques like convolution neural networks and hybrid deep learning framework consists of a combination of different pre-trained deep learning models. And coming to previous works, there are so many papers related to solar panel fault detection. Some of the papers uses the first one is hybrid deep learning model for fault detection and classification of connected photovoltaic system. These data of solar panels. So what these guys have done is they included LSTM and also autoencoder techniques. What autoencoders they have used, like they have used autoencoders to reduce the dimensionality and also to decrease the size of their features to ensure that the work will be done. So these paper is focused on is electrical faults. They have only focused on electrical faults, but there are so many different faults in solar panels. So those guys didn't mention about that, and they didn't take into account of those faults. And also the second paper that we focused is defect detection algorithm for photovoltaic module EL image based on two-stage EOLOTS. Model in computer vision domain. For any image classification or computer vision related techniques, YOLO will be used, and they used FPN and CBAM for convolutional block attention mechanism, and we took some part of this paper, that is convolutional block attention mechanism. This is for detecting the specific region of the image or what will be the defect in that particular image. Detected small cracks, corrosion spots, and the main disadvantages or gap of this paper is like they only used EL images. Like normal images will be fine, that will be available everywhere, but EL images are very limited. Like electroluminescence images are hard to find and also hard to process, and very difficult to find in the normal environment. So they performed only on EL images. So they actually performed other types of images like infrared images and normal images. And the other two papers also focus only specific type of data like infrared or EL images, not like the normal images. They didn't consider the normal images, and they did not do deep learning on those things. This is considered data set from solar panels images from Kaggle. Our data set consists of mainly 4 classes. Those are clean class, that is the major thing that we are focusing on, and the other 3 defects that we consider bird drop, electrical damage, snow cover. The reason that we consider these defects because these 3 are identical, like snow covered and also bird drop will be similar, so it will be difficult to classify for any kind of drugs focused on electrical damage or physical damage, but we want to do classification between 2 similar classes like bird drop and snow covered will be so similar that even a person seeing those images cannot find whether it is bird drop or snow covered. Even electrical damages, when short circuit or something like that happens, it will be a white fused one or a damaged one that looks like either snow covered or bird drop. So what we did is we compared the binary classification and multi-class classification. Binary classification is whether there is a defect in that or not, and multi-class classification is classifying between the clean one and what type of defect is this. So there is a lot of data pre-processing that we had to do because the data that we took is normal images of the aerial images of the solar panels. So there will be a lot of pre-processing that has to be done. So the orientation of the images are not in a particular shape. So we had to reshape each and every image and each and every class. So it took a lot of work on that, and some of the data pre-processing that we have done is converting from the first one is converting from BGR to RGB for correct color channels, and other techniques are shape so that we had to feed into deep learning models, and some normalization thing is applied so that all the images will be in the one range, and some not we had to input some noise into the images so that when a detection happens, that not only includes only clean images or the perfect images, some blur images or non-perfect images also will be trained good, and when the classification will be done perfectly. So we had to face a lot of imbalance in the classes because we are combining all the defects into one defect, that is in the binary classification. In binary classification, we are doing whether defect is there or not. So clean images will be same, but the defect images will be combined from the three defects that we are considering. So class imbalance happens. If it is a class imbalance is there in any because those will be different number of images. For clean images, there will be, say for suppose 500, and defects we have 1500, there will be a problem. So we use random weighted sampler which does create a lot of more samples by considering the average of the different images, and the main proposed method for neural network based convolution neural networks, and we did a custom convolution neural networks. In that, like, we added a few layers that are needed for the classification of images. For suppose our images need a vast data or needs to be focused on the vast area of the images. So we have introduced dilated convolution layers, not only the basic convolution layers. So dilated convolution layers in CNN focuses on data, so that the defect area will be detailedly noticed, and we use global average pooling. So if you are using dilated convolution, the area will be high. So to take the normal pooling or average pooling, max pooling will be not sufficient. So we introduce global average pooling, which adds some gaps or holes in the field to make the area high, and considering it as average. This is we took CBAM from one paper. Like we have an idea of taking CBAM from one paper. What CBAM does is it is an attention module, convolutional block attention module. It is for only convolution neural networks. So it considers spatial features and also channel attention. Channel attention is focuses on what are the detect areas, like what are the regions that you have to focus, and the special attention focuses on where is the detect effect or where is that region located in. So this helped a lot in classifying this one, but as there are so many multi defects, so for binary classification it helped a lot, and the main thing. The main thing that we have done is like the comparison between different models, CNN model and CBAM model, and now CNN ensemble learning. So what it does is comparing the input of the image, like what will be the best. So based on that, sample loading or average technique will be done, and based on that, whichever model will be good performing, so that will be classifying the input image. And the last one that we have done is hybrid training. We took two best performing pre-trained models like ResNet 50, VGGC. Actually trained this entire data set with individual pre-trained models, and the results were good compared to the other CNN models. But we thought of doing a hybrid model because ResNet focuses on residual networks like skip connections and focuses on not preventing overfitting. And also VGG16 focuses on sequential layers. So by combining these two hierarchical features and also spatial features, we try to hybrid concatenate these two pre-trained models, and these perform very well compared to all the other models. These are the results we obtained from the different models. Hybrid ResNet model got high accuracy compared to all other models, that is 97%, and other models like CBAM CNN got 84% and base CNN got 93%. And for the 4 defect classes, not binary classes, this is less because the defects are all similar to each other, like bird drop, electrical defect and all. And the conclusion is this will be so much important or so much helpful for the environmental or societal problems, because solar panel is like solar energy is one of the top renewable energy, and also we don't focus on identifying the defects or what the how the solar panels looks like. So we have to how it will be maintained, and also we have to take care of that. So our paper focuses on that one, and the future scope that we wanted to mention is like we can use supervised and unsupervised learning, like combination of that, the semi-supervised learning. So the data is so much, so it takes time to do with the deep learning techniques. So if we have some techniques and also very good, and also we wanted to do real-time monitoring, not only like images. There will be if we do real-time monitoring using computer vision based on YOLO and YOLO V8. There are so many latest YOLO versions like V8 that are so advanced. So we can do based on that, and also we can make a smart, like IoT enabled smart grids. So there are just based on that it will be done in the edge computing, not only in a lot of devices are needed for that. This is a thank you.
Somewhere you have to get connected with the end users. For example, Karnataka is the largest, one of the largest. So it's a new technique like deep learning, and you have to get connected with the BESCOM people. You should go and say, we can tell they have got a Pavagada, so much big area for a solar energy. I don't know whether they are 100% working efficiently or not. If somewhere some defects are there, they can make some rectification and try to improve. Your efforts should not limit only to the paper presentation. They have to talk to the end user, say yes, we are capable. Give opportunity to do that analysis and let us know whether something is defect in the existing system. Are you aware about this Pavagada solar system? You are from which place?
I am from Andhra Pradesh. So my native is Andhra Pradesh.
Andhra Pradesh, Pavagada is kuda Telugu ne. Pavagada is in Andhra Pradesh. You can go and see so many things. You should not limit only focus to this. Use solar energy system. Adopt this somewhere, take some modeling thing analysis and submit report to the BESCOM people. Crores of rupees they have spent, whether it is really 100% efficient electricity is being produced, nobody knows. But today you have a technology. They would have installed 10 years back or 5 years back. Users. You are working for some industry or college?
I'm a student.
Which college?
Amrita.
Where?
Bengaluru, Sarjapur Road.
Here only. Good college, you are in a good college. You should not limit this. Please go and make use of your knowledge for the end user. Good work.
Thank you, sir.
The depth of your knowledge were commendable. Now let's call upon the paper ID 1502.
Good afternoon everyone. I am Shreya. I am currently a project trainee at ISRO. Today I will be presenting our work titled A Survey on the Radiation Performance of Gallium Nitride Devices for Spacecraft Avionics. Here is a brief overview of today's talk. I will begin with how the different types of radiations like heavy ions, protons, neutrons and electrons will affect the gallium nitride HMP devices. We will also understand the different potential strategies to mitigate these effects. Conclude with the key findings. Let's begin with the introduction part. Gallium nitride or gallium nitride based devices are revolutionizing the space electronics because of their exceptional properties. Compared to that of the regular silicon MOSFETs, these gallium nitride HEMTs will operate at the higher frequency. They have an increased efficiency, greater power density, low on resistance and higher thermal conductivity. Because of all of these properties, they are an excellent candidate for the spacecraft avionics. However, when these gallium devices are like the military or the nuclear applications, they will be exposed or induced to various high energy particles. Understanding how these gallium nitride devices will degrade is very, very important for us to understand the mission's reliability. Now let's begin with the heavy ions. This type of the ions will cause the severe degradation of the gallium nitride devices. When the heavy ions are incident onto the material, there will be a generation of the electron hole as the hole pair. So there will be a generation of the interface traps, which are nothing but the defects in the material's interface. So which is the main responsibility, which is mainly responsible for the alteration of the device's electrical parameters or electrical characteristics. There we can see, so here that is the transfer characteristic of the gallium nitride HEMT device pre and post exposure to the heavy ions. From that graph we can understand that there is a decrease in the threshold voltage. And we can observe that the threshold voltage has shifted positively. The decrease in the transconductance represents the gate controlling capability of the device, which is an important parameter for the frequency characteristics. The reduced value of the transconductance can be used to evaluate the extent of the damage that has been caused in the gate area, also the decrease in the carrier mobility of the HMT. Therefore, when the heavy ions are incident, we can see that there is a reduction in the carrier mobility of the channel as well as the gate control. Next up, we have the effects from the proton radiations. Protons, which are very abundant in the space environments, will primarily cause for the displacement damage and the charge trapping. That is the input characteristic graph of the gallium nitride HEMT post exposure to 2.5 MeV protons. The data clearly shows the complex interplay of the total ionizing loss and displacement damage. Following irradiation, the devices will show an initial increase of the gate leakage, followed by simultaneous increase. You can also see there is an increase in the drive current, which is nothing but the drain current for the gate voltage above the threshold. So these results will suggest that the single event burnouts will occur for the lower breakdown voltage. Additionally, damage from the proton is also associated with the type of the substrate that has been used in the device. For example, the gallium nitride HEMT with the sapphire substrate tend to show more resilience compared to that of the substrate with the silicon carbide. Interestingly, the electrons will show the improvement in the electrical characteristics of the device under the controlled exposure. We can see there is an improvement in the 2D electron gas density as well as the cadmium mobility of the channel. That is because of the strain relaxation or the defect reordering. The first graph we can see here is the transfer characteristic graph of the gallium nitride HEMT post exposure to the heavy high energy electrons. There we can see the improvement, the increase, drain to source current, and the threshold voltage is shifting in the opposite direction. And from the second graph, which is the output characteristic graph of the gallium nitride HEMT, we can observe there is an increased pattern of saturated drain to source current. That is when there is an increase in the electron planes. So these results will suggest that there is an improvement in the device's electrical parameters or characteristics post exposure to the electron radiations under controlled exposure. Finally, we have the effect of the neutron radiation. The neutrons will interact with the materials quite differently. They'll form the deeper level traps, which will affect the charge trapping and the de-trapping mechanisms. That is the output characteristic graph for the three different samples. First sample is for the unstressed and the non-irradiated gallium nitride HEMT devices, which has been represented there with a solid blue line, which has been characterized with the high amount of the drain current and the low level of access resistance. The second sample is the stressed and the non-irradiated device, which has been represented over there with a red colored dashed lines. Compared to that of the previous sample, we can see the decrease in the drain current level, but there will be an increase in the access resistance. And the final sample is the stressed and the neutron irradiated devices, which are represented over there with the green dotted lines. So comparatively here we can see the improvement in the drain current, but the access resistance has remained unchanged. This neutron is specifically applications or the nuclear applications. We move on to the conclusion. Our study suggests that while the gallium nitride devices are being resilient to total ionizing dose and the displacement damage from the protons, they will remain vulnerable to the single event burnouts. Because of these radiation effects, there will be shift in the threshold voltage, on resistance, transconductance, and many more characteristics. This is mainly because of the trap dynamics, which are responsible for altering the device's electrical power. Now we move on to the device improvement strategies. In order to improve the tolerance of the device for tolerance capability of the device for the radiation, we'll be following the different techniques. So the first one is the process level technique, which is called the radiation hardening by process. Here there are 4 different processes. So the first one is by doping the different elements like the magnesium and the carbon into the gallium nitride, which will improve the stability of the device for the irradiations. The second one we have by layers is substrate and the gallium nitride, which will reduce the appearance of the defects essentially. The third one is by introducing the passivation layers with silicon nitride or silicon dioxide on top of the gallium nitride HEMT device. This will reduce the surface effects which are caused because of the neutron irradiations. And the fourth one is by introducing the vertical gallium nitride structures. These vertical gallium nitride structures have an inbuilt property, that is higher thermal management property and high down voltage. To make the resistance capability of the device. The second technique we have is the circuit level one, which is called the radiation hardening by design. So the first process over there is the redundancy. By constructing the redundant circuits or the fault tolerant circuits within the gallium nitride based systems will help for to reduce the complete failure or the destruction of the device upon exposure to the radiations. The second one is biasing and the control techniques. Here we are providing the additional making the designer changes. So by increasing the space between the gate and the drain, we can increase the robustness of the device for the single event burnout. So these are my references, and thank you.
How do you find the practical implementation of these things?
Okay, so we can really make use of English units in case of the space, especially in the space contained units, in the DC to DC converters because of their high efficiency and high voltage switching circuits compared to silicon and or the silicon carbide. These gallium nitride devices will switch or operate faster comparatively.
How do you make ensure that this can work in the real-time applications? Many works have been done.
Yes, so the radiation testings are yet to be performed in the URF satellite center. So we are working on that.
How is it this?
Oh, it's great. I mean, there are like 3 tests that needs to be done. So the first one is total ionizing dosage, second one is the displacement damage, and the third one is single unit effects. So we are going to perform all these 3 testings. So far whatever the studies that they have done is only for the commercial devices. So whatever that we are going to do, it's going to start from the next month. So we are going to apply it for the spacecraft applications. I mean, we can use these.
Small doubt with that. The atmospheric feature of Earth and the atmospheric feature of this moon or space might be different.
Yes.
And then the metal corrosion or the metal oxidization might vary. How do you get it as a chance to make ensure that this works in space?
So they will create an environment such that it should be something that is similar to, or it should be like similar to the space, whatever it is. So the sources will be something similar to the the radiations that may affect our device in the space. For example, the cosmic rays or the solar rays are the main thing or the main sources of the radiations that will affect our devices. So similar to that, we will use different sources in our laboratory. For example, in case of we make use of the krypton, orium, or the nickel. And similarly, we have different sources. Like in case of electron, we have tungsten and cesium. In case of the lutetium, beryllium. So such cases, we will make use of the different sources that will be similar to the radiations that will affect our device in the space. Thank you.
Are you suggesting we should go to spacecraft and work on this type of technology?
Oh, definitely. Definitely.
Take an opportunity, don't limit your, I told you in the comments,
Yes.
don't limit your thing. Work hard, work hard.
Thank you. Thank you.
Thank you for the knowledgeable presentation. Now let's call upon the paper ID 1971.
Good afternoon, sir. I am Madhav Menon from Ankitha Bengaluru campus, and our paper analysis with algorithm and deep deterministic policy gradient model for autonomous navigation inside indoor environments. And our key motivation was to provide autonomous navigation in indoor environments for various purposes, such as for smart wheelchairs and vacuum cleaners and other things. So we were planning in order to do this by intelligent path planning and real-time obstacle avoidance. And for this, the various other applications includes mobile robotics, which we were concentrating on providing results for. And the literature review was based on the 2 different algorithms, study about them. One is A-star algorithm and other is deep deterministic policy gradient machine learning algorithm, which requires a lot of training as well. And there are works which are done already and based on each of these algorithms, but we were able to do a comparative analysis between the appropriate navigation and also provide simulation results for the same. and represents this algorithm's navigation through wireless communication using ESP32 modules. And this is our approach or methodology which we have used, and in this we used various ultrasonic sensors in order for real-time obstacle detection, and ESP32 microcontrollers for wireless communication between our system and the prototype which we made. And along with that, both the navigation algorithms have been implemented in our simulation platform. The time through this ESP32 module, and using an L298N motor drive, PWM pulse is being sent from the ESP32 to the motor drive, and the battery operated motors will be used for moving the bricks further. And for testing of both these algorithms, we simulated in a 60x60 unit grid platform, and in the A-star algorithm there was discrete and grid based, and for the DDPG algorithm it was showing us continuous and learning based navigation, which was taking time. Moving on to the A-star implementation, this provides the simulation result which we have obtained using various simulation techniques. And as you can see, that one of the limitations which the A-star algorithm was showing was that it was only giving us discrete movements, that is either front, back, left, right, or forward motions, whereas the time of computational time when it comes to A-star algorithm, and the core main function of A-star algorithm is that there is a cost function which has to be minimized, and at each point, if there is an obstacle faced in the grid, then the cost function would be high. So in order to minimize that, the path would be avoided, and the grid would be updated that there is an obstacle over there. And for the obstacle detection, there is ultrasonic sensors which are being used. And deterministic policy gradient works on a different aspect, that is, in the previous case of A-star, it was to minimize the cost function in order to as such. So in the simulation platform, the deterministic policy gradient model requires a lot of training itself, and we have to simulate the indoor environment which we have in real time in an online simulator. And the deterministic policy gradient model will start training on this for multiple episodes. We have trained for around 500 episodes, which took few hours of time. And at each point, when this navigation is happening from the starting to the end point, at each of the scenes, if there is collision in the rewards point given to it, and if there is no collision and movement towards the end point is happening, then the reward points is being given to the model to understand that that is the most optimal path in order to reach the destination. And yes, provide of deterministic policy gradient model, even though it takes a vast difference of computational time, as told here. This ML model training was capable of doing also continuous motion and also more smooth and real-time motion, which is more capable as compared to human movements. That is, even slant motions and backward motions were capable of doing. And the performance, of course, A-star algorithm remains 100% successful, and it was taking a 0.15 second for the path planning. But the model was working up to 95% and was taking a lot of time in computation because it needs an online indoor environment simulator, and on the simulator it has to be trained for multiple episodes. And the response time is around 0.3 seconds if it faces any obstacle which is dynamic obstacles, that is any moving obstacle in the environment. If it is present, then that will be noted by the sensors, and accordingly a new route will be given. Of the same, we use a small three-wheeled robot in order to represent our working of our comparison, and we were using ESP32 controllers and ultrasonic sensors and battery. There was L298 motor drive and the battery power bank which was there, which was providing the necessary power required for all of these components. And sensor integration was given at 3 points in order to notice there is any obstacle on either of the side or in front of the robot, and the motor control was via PWM pulses given by the ASP32 microcontroller, and step by step we were able to implement and also validate the results by hardware implementation of the same, and we were able to observe that the discrete movements provided by the A-star algorithm is successful in every case, but when it comes to real-time and smooth operation, deep deterministic policy gradient model is better because it was able to provide us continuous motion rather than discrete motion. But the computation and training is more time-consuming as compared to A-star algorithm. That is the comparison which we were able to understand, and both these methods have its own pros and cons, and depending on our application, we'll be able to choose. And the future work and the conclusion that I told now were the major findings, and we are working on getting in touch with companies like Yaskawa and Peppermint Robotics in order to implement our comparative analysis and smart wheelchairs for automation as well as vacuum cleaners for indoor environment cleaning purposes. Thank you, sir.
When you are using with the A-star,
Yes.
Why not with the A-star?
Both of these algorithms,
So we were provided guidance by our professors at our college, and we were guided that try this out. Coming to deep deterministic policy gradient, it was our own work, but when it comes to A-star, we were trying to only implement simple movement for discrete.
The heuristic approach.
Yes.
Heuristic approach. You have only and condition with A-star. In A-star, you have and or, which gives you a robot to move in some directions. But when you compare with your DD, there that might not be limited. So what was my thing is, if you have used A-star, A-star, and you can put it with DD. That's my thought. I don't know how it has been approached. Then when the robot moves, you have a proper simulation model. The obstacles cannot be at the right moment. Obstacles can be anything. How is your robot trying to understand?
So when it comes to the online platform, it is a static environment which we are able to provide. But when it comes to real-time implementation, we are providing the robot, on the robot we are providing ultrasonic sensors in order to detect any obstacle which has a Wi-Fi module for communication. And in our system, the process will happen in order to upgrade the grid which is present. And if there is an obstacle there, it will be updated and a new will be time taken for A-star is 0.15 seconds, and for deep deterministic it is 0.3 seconds after the training is done.
That time elapsed should always reduce.
Reduce, yes, yes.
Huh? Good.
Thank you, sir. Thank you very much. Training.
Thank you for the insightful presentation. Now let's call upon the paper ID 2198.
Good afternoon, dear. Myself, Ganesh DC, Assistant Professor, Department of Engineering, Science and College of Engineering. Today I'm going to present my paper, titled Statistical Evaluation of Ultrasonic Welding Parameters for Weak Poly using Vijayasimha. So basically, the paper studies a novel correlation between the input parameters what we use for ultrasonic welding, and we are correlating that with respect to the output parameters, basically the mechanical parameters, namely the shear strength, the hardness and impact. For this, we are using polyether ketone, which has a wide range of applications in aerospace engineering, automobiles, as well as medical applications. So it is not only that we are adopting one good method of welding polymers. Basically, we have to adopt one eco-friendly process, that is ultrasonic, which offers a clean, fast and economic way of welding the polymers basically. And then finally this statistical insights which we have adopted appears correlation for bonding and intelligent process control. So basically nowadays industries globalization taking place which are looking for eco-friendly manufacturing process. Exactly molding two parts of a polymer into a single thing. So nowadays whatever the devices we use, headphone chargers, mobile chargers, adapters, polymers. So everywhere polymers can be which are ABS, DMMA or it may be PEEK. So here we are focusing on the PEEK polymer and the correlation what we have that is ABS. There are the literature reviews what I have studied for my paper. So thereby we have identified some of the gaps where exactly the ultrasound value is of course adopted, but proper statistical tool usage is not done, so that we can judge the input parameters effect on the outputs, how exactly output parameters are getting affected. So for this, in this research, the visual tool whatever we are adopting, so that we can see visually what is the correlation of each individual input along a simple data-driven approach to better understand and optimize the peak ultrasonic welding. This is the experimental setup which we have in our advanced welding laboratory at the Vijayasimha University. So basically, ultrasonic welding works on the principle of a transducer that converts electrical energy into mechanical vibrations. Thereby, it will be boosting by means of boosters. Then the horn whatever we are using, which is applying the pressure. Applying the heat specifically will be produced thereby the applying pressure while the polymer state. This is what basically happens in case of ultrasonic welding. This is the sample what we have welded of a PEEK polymer. So here the horn applying pressure on the two clamped PEEK polymers, thereby creating the heat and it's welded. The right hand side image shows the welded part basically. So here we have done some 27 trials by varying the different input variables like time, amplitude. The mechanical properties like shear strength. Shear strength means the stress, how much a material can absorb before breakdown. Then impact energy, the energy absorbed by material before fracturing out. And the hardness is basically the resistance of a material against breakdown. Okay, so all these three properties are measured with respect to the variation of the force. So just by making this, we are just making the trial, but we don't know how individual parameter means the time, maybe the amplitude of light. So for that, we have used the Pearson correlation matrix, which is a statistical tool which gives a strength and a direction of a linear relationship between the input and output variables basically. So it gives correlation constant +1 to -1, where exactly +1 indicates positive correlation, -1 negative correlation, 0 there is no correlation. This is the empirical formula which we use for calculation of Pearson correlation matrix. The variables what we use, one input and one output, then x bar, y bar are the mean values of two inputs. So thereby by using the Python OpenCV, so I have generated one correlation matrix, Pearson correlation matrix. Here we could see how exactly the four input parameters are affecting with respect to the mechanical properties like shear strength, impact energy and hardness. So among three, the weld pressure having an impact around 0.84, 0.81 and 0.7 with respect to the hard vibration and the hold time. And weld time also considered, but it can be made constant before the welding process are optimized. So other things are held constant because they are correlated to one each other. So this is what the correlation coefficients we have calculated on each output parameters, basically the mechanical parameters, how they are affected by each and every weld. Where exactly weld pressures having a more effect on the mechanical. This bar chart also shows such visual representation how exactly the pressure makes an impact followed by the amplitude and hold time along with the weld time. So in conclusion, I could say the weld pressure should be optimized, prioritized during the process of optimization due to its substantial impact on the mechanical outcomes, followed by the amplitude and hold time. That can also be optimized, but where exactly the weld time can be held constant. So these are the references.
How do you integrate? This is, I think this is your PhD work. Right?
Yes.
Actually,
Not only this, we are into the image processing also, based on MATLAB and Python. So basically what we do, this is going to be part of my research work at present. So even we are working on ABS polymer, so there also we have XRD analysis, FTI analysis, and PMM polymer set images. On that we are doing.
do you keep any threshold for all these categories?
Sir?
Thresholds are there for these categories?
No, basically whatever the trials we are doing, based on whatever we are getting, so based on that the test we are doing.
Why 127 trials?
That is Guachito method we have, so 3 into 3, how many input variables. Those are there in step 3 into 3. So again, so it will be what array of Guachis to one kind of array we got.
You have multiple arrays in that.
Yeah.
Yes.
Yes. So that I will just Sure. Thank you, sir.
Everyone please scan the scanner and provide the feedback.
Yes, sir. Yes, sir. This is the reference presented. Yes. Okay. You should be directly proportional, not indirectly.
Now, we would like to take a special moment to extend our heartfelt gratitude to Pradeep KS sir. Sir, your presence have been a source of encouragement for all of us. On behalf of the entire organization team and participants, we sincerely thank you for being with us today and for your valuable support. Kiran Kumar N. sir to come forward and do the honors. Please give them an applause.
Good evening or good afternoon, I don't know. All the papers were nice, students evaluation. I thank Vemana Institute of Technology for inviting me as a session chair. I was delighted to see the papers presented with the topics. All topics were related to the modern technology. And a suggestion from my side is, don't restrict yourself with only with that paper. Please enhance it to the next forward versions. And as a student, you are still in second year or third year, I think so. Make it a hobby to try to implement in the real-time application, get the outputs in a fast manner. Thanks a lot for the Vemana Institute to Mr. Dr. Kiran sir, who provided me a good hospitality and throughout the session. The anchor was also good, doing a good and nice presentation. Thanks a lot.
As we conclude today's paper publishing session, we extend our heartfelt gratitude to all the participants for their remarkable efforts, to the judges for their insightful evaluation, and to the organizers for making this event possible. True to the words, knowledge shared supplied our understanding and inspired us to think deeper. Thank you for all your presence and support. Have a wonderful day ahead. Now let me call upon the participants' paper ID and get your certificates. Paper ID 68.
Nirmit, call Nisa to stop it.
Should I stop? You can stop streaming. Broadcast I can do. Come out, let's see.
Everyone please come up on the dais for the group pic.
Photos available? Will you share? I don't know. You don't know? Can you capture one here and see? Okay, sure.
They want it. This one. It's your tag. Oh, okay, that's there. No, stop it. Stop it. It's going on.